In part 1, we talked about why hybrid systems are so powerful for creating smarter NPCs. Now let's get practical. We're going to compare two ways to build those hybrid systems inside Unreal Engine. A system combining state trees and behavior trees, and a simpler approach using just state trees. By the end of this video, you'll know exactly which one is right for your game's NPCs. Alright, so you've seen how powerful smart NPCs can be, but how do we actually build that intelligence? Let's quickly revisit the core ideas of part 1, because understanding why these systems work is key to building them well. Think about an AI guard. They need to be in one state at a time, idle, alerted, searching or reloading. Finite state machines are perfect for that, clear, simple and predictable. But what happens when things get complicated? How does that guard decide where to search, or what makes them suspicious in the first place? That's where behavior trees shine. They can juggle multiple questions at once. Is the player visible? How much ammo do I have? Where's the best cover? They're amazing at making complex decisions, but can quickly become messy if you try to use them for everything. The real magic happens when you combine them. Think of it like this. The finite state machine or state tree in Unreal Engine says I'm in search mode, and the behavior tree figures out exactly where to search and how to move. It's the best of both worlds. This hybrid approach gives you the organization of state trees with the decision-making power of behavior trees. Let me show you the test environment. It's a simple maze level that will allow us to see both AI approaches in action. You may recognize this level from these videos. The player starts here. Moving towards the exit, you'll encounter the first NPC positioned in an enclave at a left turn. This is a classic ambush position where the guard has good visibility down the corridor, but can take cover if threatened. You'll lead an immediate right turn, then a straight section, followed by another right turn into a room. Here is where our second NPC awaits, positioned near the exit. This NPC has a more complex tactical situation. They need to balance guarding the exit while having multiple directions to consider. The state trees in both scenarios handles all state transitions through a single evaluator. When the player is spotted, it will switch to alert. When out of ammo, the evaluator will switch to reload. When losing sight of the player, will switch to search. When none of the above is true, it will switch to idle. The evaluator runs continuously, ensuring responsive state changes. Let's start with the hybrid approach. Here, we're using a state tree for state management and a behavior tree for complex behaviors within those states. Our state tree structure is straightforward. The root level has our four main states. Each state has an entry condition. The primary task in each state is run behavior, with a different behavior tree for each state. Okay, so what happens when we ditch behavior trees completely and build everything inside a state tree? It means more structured hierarchical approach to NPC control. Everything from simple animations to complex actions is dictated by the current state. Let's start with idle. This isn't just about standing still. It's about showing the guard is relaxed and observant. So the logic here is simple. Stop aiming and play that natural, believing idle animation. This sets the baseline for the NPC's behavior. Now the NPC enters the guard's vision. This triggers the alerted state. The immediate response? Focus on the player and lock on with aim. This is about quick, decisive action. The guard needs to react instantly. If the player breaks line of sight, the guard enters search mode. It's not just about wandering, it's a calculated move to the last known location, followed by a thorough scan of the area. This state is about persistence and determination. Finally, when the guard's ammo is low, it enters the reload state. This isn't just about triggering an animation, it's about prioritizing self-preservation. The guard stops aiming and reloads its weapon, preparing for the next encounter. By building all this logic within a state tree, we create a predictable, controlled NPC. It's less flexible than combining it with behavior trees, but it's incredibly efficient and easy to understand. And most importantly, it creates a believable and immersive experience. State T represents the evolution of game AI systems. It's designed specifically to handle the hybrid approach natively, giving you the benefits of both finite state machines and behavior trees in a single optimized system. But don't dismiss the hybrid approach. There are scenarios where the separation of concerns and behavior usability make it a better choice. The world of AI implementation is constantly evolving, and Unreal Engine's State Tree system represents the cutting edge of what's possible in AI development. What are your thoughts on this? Let me know in the comments below. See you in the next one.